when there was no hype about AI, you are researching on AI in Shanghai and in Carnegie Mellon University and etc. I thought I should ask about AI. How can someone learn about AI, and how can someone can stumble upon AI and chip design? But after seeing your journey, I thought it would be great if you share the whole story. Where are you born? Where you went to schooling, college, and stuff, briefly, so that people can understand the nuances. So, can we? Are you comfortable in that way? Can we start from there?
So like you said, like I have been working on this AI for chip design, and the really the starting from Carnegie Mellon, right? So and that was sort of related to what I've been doing right now. So I did my PhD at CMU between 2018 and 2022. Spent about 4.5 years there, and doing a bunch of things, research, taking courses, but the focus is really on a DARPA project,
Hold on a
uh,
second. It's
focusing
going
on.
out of my brain. So let's start with Shanghai University. Where did I start? And give me a bit of background about where were you born, in Shanghai or out of Shanghai, and how you got into Shanghai University and stuff. Let's start from there.
Yeah, so yeah, that was like a long time ago. Like so from college, so I started like so my college actually my undergrad and sort of master program. So I was more on the engineering side, focusing on like mechanical engineering and material science. Back at like, Shanghai, Jiaotong, and it was interesting period of time. And I think the education for like the Jiaotong for my undergrad like university, it was you learn a sort of bit of everything. So although my focus was on like mechanical materials, mechanical engineering, material science, kind of get exposure to different areas of engineering, mechanics, electrical, a lot of other stuff. And I came to the States 2017. So I did my undergrad in Shanghai, and then like the master program was like I have a dual master program at both the first 1.5 year in Shanghai and the next 1.5 year in Northwestern University here in Chicago in US. So at that time period of time, that whole period of time was still focused was on mechanical engineering, material science. When I just came here in 2017, I did some research at Northwestern focused on 3D printing, additive manufacturing, which is pretty popular topics these days. Those days, and
Especially in China, right? It is manufacturing is very, very vital. And it's the backbone of China, right?
yeah, so the manufacturing, yeah, I was focused on manufacturing, yeah. Um, But I came here, so just still doing the first 1 2 years, still doing some of this 3D printing, additive manufacturing thing, and then started to realize that at that time, I mean, the deep learning AI is getting machine learning is getting popular, and just started reading stuff on that front and getting feel like it's like more interesting ways to go, and started picking up, basically this related math like statistics, machine learning courses, and getting more proficient in coding because my undergrad I didn't do that much in programming honestly, so I have those courses for my undergrad like in Shanghai Jiaotong and for my master, but that was pretty preliminary. I think course based, nothing much I would say. So I would say I started like programming pretty late compared to this younger folks these days. Um, so anyway, so that was the first part, like my undergrad master program, and then I applied for a couple of PhD program. So because my thought at that period of time was that I was considering doing research, maybe becoming a researcher or professor when I was in my master program, and they applied a couple of PhD programs, and I think get 3 offers. So I took the one from Carnegie Mellon. So because at CMU I was able to get chance to work with two advisors, one from CS department, from computer science department, another from engineering. So I think that's the best way for me to sort of getting more exposure to the like ML like top researchers and professors. So I just decided to go to Carnegie Mellon to do my PhD program. And I think another important, interesting thing that so really I uh, decided to go to Carnegie Mellon, which also I think is a very like looking back is a very good opportunity. Is that my PhD program was funded by a DARPA project, which is DARPA is like to give you some perspective. Is DARPA is basically this. The full name is like this, Defense Advanced Research Project agency, but basically it's like a U.S. basically Department of Defense their research arm, basically funding a lot of this uh, very frontier research. So my I was lucky like my professor get one of the DARPA project, and so my whole PhD program was actually funded by the program the project, which is focusing on AI for chip design. The bigger hat is AI for chip design. So take a course there and so do the research, focusing on this DARPA project, working with both university professors, my advisors in CMU, as well as some industry folks from NVIDIA and Cadence. Yeah, so so
A couple of questions here. You are doing good in Shanghai, and China is pretty known for manufacturing. Why haven't you gone for doing a job rather than decided to move to US and do research? What was the thing?
yeah, yeah, that's a. I think that's a interesting question, right? So, and actually, yeah, I have thought about that. Like, first of all, I think one motivation that I want to, haven't just studied abroad at that time was mostly in China. I want to see what's happening like elsewhere. I know, and also overall the like ranking of the U.S. universities better. So that's one consideration. But I think you are exactly right. I think it's, in terms of manufacturing, I would say like Shanghai is, and not particularly Shanghai is like the area around Shanghai, like basically this coastal area, like in around Shanghai is like a manufacturing hub. And through my so at Shanghai, at my undergrad and this master program, so I was doing some research on like additive manufacturing, 3D printing, and got exposure to some industry folks. So we were doing this 3D printing, additive manufacturing um, research experiment. So I got a chance to travel to the factory in Suzhou, which is like a neighboring city of Shanghai, where there's really a lot of manufacturing factories there. So I was able to talk to this kind of really the entrepreneurs for this manufacturing business. Basically, I do experiment in the Suzhou company. They were manufacturing 3D printing machines, which is very good. They were like making a lot of money. The thing is basically they are building the additive manufacturing machine, selling it everywhere. So it's quite interesting, and it's quite it's much cheaper. It's like maybe one third the price of the counterparts in Europe or like in United States. It's very competitive. But I think one thing for myself I realized is that like manufacturing is really a very tough business. It's like so that experience really helps me because I was doing additive manufacturing and at that time I was wondering, hey, should I do this? I in academia industry, like continuing on the manufacturing front. And then I realized it's like as a person or as a either it's probably not a good. It's a very tough career, I would say. Like I visit the factories in Suzhou, and then like the business owner, the boss, the owner of the company, like he's making I don't know, like maybe three 3 million, 4 million like US dollar in profit per year. It looks pretty good, but at the same time, he has to reinvest to develop the next cycle of machines, the additive manufacturing machine, within the same year. So basically, he has to keep spending um, the profit into the reinvestment, and in order to be basically get competitiveness in this business. So it's I realized that manufacturing is good, but it's like it's very as a if you want, yeah, it's very investment, it's very capital heavy. So if you want to do that as a, so that has two implications, right? So first of all, if you do that as a business owner, so you will always have the pressure of this capital pressure, right? So to keep reinvest, so that eat up your profit. And the second thing is that if you do that as an engineer in manufacturing, um, that means you usually don't get as paid as well as maybe software engineer or like other careers. So that I realized that is not something I really want to do. And I think also one important thing is that so this is the like this realistic considerations, right? So another thing is that, so I have always wanted to do new things, explore new things, and doing some creative works and see its real impact. But I think the manufacturing is that because it's capital heavy, it's the things you have to do, like real experiment. You have to do things, innovate in the real world. So that means the cycle of innovation is very long. Like for instance, we are trying some new techniques to do additive manufacturing. It takes several months to do the first round of experiment, and then you do a bunch of analyses, and then do something. So I think the cycle is very long. So I decided that I want to overall I want to doing more kind of the software side of things, and then so that also combined with another decision to try to go to study abroad for my grad school. That's both, I think, both reasons driving me to study like focusing more on computer science, machine learning versus the manufacturing.
Mhm.
Yeah.
But how did you got into that decision? I mean, turning into computer science. What made you turn towards computer science and stuff?
Yeah, I think that, so first of all, I think it's out of, it's two things, right? So first, like as I have some friends back at undergrad, like they travel to US first, and I think frankly, like 10 years ago, I think the information gap between China versus US is bigger than today. And then like, I have some friends who's just started studying in University of Michigan, Ann Arbor. Like he has this dual bachelor program, and he come to States earlier than me, and they were taking a bunch of ML deep learning course. And then just he came back to Shanghai, and we were discussing what we should do in the future. And I just started, and he told me like my friends go to U Michigan, told me like, hey, like this is the future, like the machine learning, deep learning is going to be becoming popular. So I think there's some kind of this kind of information, and it's pretty much out of this information and out of curiosity, I started, diving into this machine learning field. Um, yeah, but anyway, I think overall, back to that was about like 10 years ago, right? So the back like 2016, 2017, back at that time, the popularity
Was pretty low.
or
We were talking about pre Chat GPT, right?
yeah, that was like nothing close to the popularity, the heat these days. So it was maybe two orders of magnitude less popular. Yeah, but still, people are slowly, maybe in academia, like in some like fan companies, people started discussing, but nothing close to these days. Yeah, yeah,
Have you ever experienced this? There are so many experienced guys. Like you are in sitting in 25 at you are 25, right? At that point of time when you are into deep learning and stuff and you are researching, right?
yeah,
Yeah. Have you thought
yeah,
there are a lot of people ahead of me? Even a 20-year-old code is better than me. But
yeah,
uh, but how did you started from scratch? And you started from scratch, right? You had a basic knowledge of how computer works in undergraduation, but
Yeah, yeah.
yeah, how was the thing went on?
Yeah, that's a good question, right? So, because I would say, so first of all, because like we said, the AI popularity is like maybe 10 times less than what it is today. So first of all, overall impression is that yes, there are people who's in the field already for a while, but not that much. So I think 2026, 2027, like 2016, 2017 was the time, like in schools, universities, people starting to uh, jump into this area. And this is not like historically, if you look at the longer history, right, this has always been like boom and bust cycles of, in terms of people's interest in AI. And so I think that period of time was this wave was the beginning of the wave we are in right now. So that makes me feel like all this, so regardless of majors, right? So at that time, for all the engineering students or the other like non-STEM students. So when I was at Northwestern, so people are like from different majors started taking course on this AI ML. So and feels like everyone is sort of starting from scratch more or less. Maybe I'm less in terms of coding or like others one, but it's like it feels that way. And I think the second thing is that there's so I have been always been focusing on the application side, frankly. So, I'm not like kind of like math or like theoretical computer science person where, trying to figure out the convergence rate or like figure out a new optimizer or like figure out a new architecture kind of person. So I think my focus hasn't been there. So if you are gonna be in that field, maybe you need to like long to start earlier. I don't know. So, but I my focus has been really on the application side. So it's really like having. So when I was doing additive manufacturing, this manufacturing side, I have been trying to look at opportunities to apply machine learning AI. Um, and that was in the beginning of my doing this AI ML. So I've been looking at the application side, and if you look at the application side, especially back to 10 years ago, even nowadays, right? Like I'm doing AI for chip design. If you look at the application side, it's more like the person working on this field is still very limited, I would say. So because if you work at the intersection of AI and a vertical, um, and especially it's a niche vertical like chip design. So usually there are not so many people who is doing that, and I feel there's still a space for me to do that overall. Yeah, that's my take. I mean back then, and I think this is still true these days, right? And
Yeah,
it's coming.
because you have the
So
underlying knowledge of manufacturing and you have the uh, deep knowledge in AI. So you intersect these and you have a new super very niche skill, and you have a very 1% in the niche, that very less
yeah,
chance to somebody a 20-year-old can come and sit in your position, right? Because it takes a years to
right,
learn
right.
about manufacturing and a lot of experience, a lot of research in AI
Yeah,
as well,
yeah.
right?
Yeah, now I think now with this AI or with this ChatGPT, people can learn stuff much faster.
I don't think so.
Yeah, yeah. So it's different. Yeah, but I also think like as an individual, like if or as a like a entrepreneur, like if you want to start some business, I still think even these days. So it's the same thing, right? If you're trying to start a business today, like it's the same thing as choosing a major or choosing a direction at a school. It's similar, right? So I would still think the more opportunities will still at the application side because if you are focusing on the infra, on the on developing the models, kind of that is very crowded and that is the competition is very fierce. And I'm not, and it's not clear like if you're working on model, right? If you're working at OpenAI or Anthropic, I mean there are a lot of great researchers, they can maybe find jobs elsewhere. But I think as the business, right? So I think the model provider, I don't think it's not clear that it will be profitable, right? Because the model is like we have open source model, and even if it's closed source model, there are multiple providers, and it's not clear that will be profitable. I think application there's still like a huge vacuum to fill. Yeah.
In my perspective, in what I think, the person who is building the application should have the fundamental knowledge of what he's building, because these foundational models are these general purpose models are trained on a general data. They're not good at it. They are good at general tasks, but they are not very good at a specific task. Let's say I wanna I wanna do a podcast application like this. It can do a basic podcast application, but with this kind of architecture, maybe it can't. We have to train that in a way. I think so, based on my knowledge.
Yeah.
What do you think?
Exactly. Yeah, exactly. Yeah. So let me repeat your question. So you are saying like, if you're doing application, does the model, can we use general purpose model, or like, do you think or like, is it like we have to use special purpose model? Is this your question?
Yes, in a way. Let's break down this. What is special purpose model for the people who are new to AI? What is special purpose model and what is general purpose model? Let's start in that way.
Yeah, I think for me it's like, usually based on the current paradigm, right? How people works, the general purpose model is like, this model providers like OpenAI, Anthropic, Google Gemini. So these are the top. So they do the pre-training with all the data. They do the pre-training with all the data they can have by crawling or by whatever. So which is supposed to perform basically better all kinds of tasks, like the general tasks like reasoning, like doing math, like Q&A kind of thing, or visioning tasks. So this like general purpose model. So this pre-training and post-training for this bigger company, and this special purpose is like, for instance, for chip design, right? So you want to do particular kind of things, and so maybe you need to kind of doing some fine tuning and alignment to basically let the models perform better in your specific focused application area. That's my understanding. Yeah.
That does my question. Wait a minute. How can someone decide whether they can whether they should use general purpose model or specialized models, which is trained by or fine tuned by them or whatever it may be?
Yeah, yeah. I think that's a great question, right? And there's no really. I think it's like it's very empirical, I would say. So there's no strict answer. I think like from last year, 25, like recent 1 or 2 years, people has been leaning towards using general purpose models, even if they are doing specific tasks. I think because I'm working in AI for chip design, I can give you an example for our industry, like for our area like AI for chip design. Um, there's I mean bigger company, they are mostly doing they are less active on AI, agentic AI. For like mostly it's the most active ones adopting AI is the startups. So for AI for chip design, there's like maybe 10 or 20 startups, and I think, and they're working. So first of all, they are working on different tasks, right? Chip design, you have a lot of things to do. Like you have verification, you have physical design, you have and in physical design there are a lot of areas. So there are different area, and these startups working on different focus areas of chip design. So, but I think like 90% of them is using this general purpose model. Um, and I think the reason is because so there are like multiple reasons. For instance, training a model, like fine tuning a model, like bigger model in house is very expensive these days. And usually, and I think most important of all is like secondly, probably also most important reason is because the general purpose models, so they have been keep iterated and improved by these bigger companies, by model providers like OpenAI and Anthropics. So it's usually the best. Even if you're trying to fine tuning something, um, it's probably not gonna be as good as the frontier, the general purpose models. Um, and I think that's tied to a third question, like it's like what do you use with your model, right? For instance, for us, for AI for chip design, like for instance for GenAlpha, like what we do is to mostly doing two things. It's like reasoning, right? So think about what you do, and then doing true calling, right? So the agent, the model itself is not doing chip design. So it still ends up being doing calling the tools to do the chip design. So for these two things, really the general purpose model is the best, and it's really good enough. So really there's no need to um, do like fine tuning per se. So because the task we are focusing on the is mostly reasoning and true calling, which is like anthropic models, they are very good at it. So like doing further fine tuning, I mean, we can try that. It's good. It's a good project, but it's like we didn't see immediate need to do that, especially considering the cost for training for fine tuning is very expensive. Um, and so there's a bunch of other technical consideration, right? It's like maybe you can put things in the context instead of fine tuning. There's some papers discussing that. So yeah, and I think these are all like the technical considerations, right? So and I think like at a high level, like if you think this model like AI as like electricities, right? So it's like it's more like this is like a paradigm shift. Like before, like maybe when I was doing PhD, like 5 years ago, people are training models, right? So like we are training like I'm training models for my research project, right? And so yeah, these general purpose model, like Anthropic model, Gemini model, so I think they are really a paradigm shift. And the paradigm shift is like becoming is like if you train your own model, it's pretty much like having your own power generator, like your diesel based power generator in your house. So versus the using these bigger models APIs, is sort of like you have this electric grid and you just get your power out of the electric grid instead of having your own generator. Um, and I think this has been this kind of electric grid kind of model, like which is the general model, has been the trend these days. Yeah, so you don't have basically if you have your own generator, you have to worry about whether it will work. Get your diesels to generate the electrics, and also, but if you just plug into the power grid, you don't need to worry about the stability of the power or like the whatever, right? It's always there. So I think it's like that. I think. But I think it's still but people has been compared this general purpose model, right, to this and like as an industrial revolution, right? Compared to this electric this like compare this intelligence of the model to electric. Um, but I think it's still different. It's still very different. So because I think the pattern like people use this model is still not consolidated. So maybe after 1 2 years, people will realize, hey, maybe everyone needs their own models on their own at home. Maybe it's like it's yeah, it's very
Got
yeah,
it.
it's
I think we still having.
ongoing.
I think so many people have still having the debate, like owning the general purpose models, or making their own model. I think
Yeah,
they're going to starve, I guess, because they are backed by billions of investors. I mean, they are backed by
yeah, yeah,
billions
yeah.
of dollars and great investors, and these
Yeah.
general purpose models or foundational models are backed up by companies with huge funding. So, in my personal,
Right.
yeah.
Yeah,
Yep.
exactly. Yeah.
Then after that, we cut down your trajectory to uh, what you are right now. So let's continue after what happened in Nvidia.
Yeah, so NVIDIA, so it was like a intern project. So because I was discussing the startup project at Carnegie Mellon, right? So and that was interesting. So I was lucky to get involved in that startup project because I was a collaboration with NVIDIA and Cadence. So because of that, I'm gonna get to know some researchers from NVIDIA, and then the NVIDIA experience is more like a research intern I did at 2021. So there I was most focusing on generating some like digital standard cells, basically some component for the digital chips with reinforcement learning. But I think at that time it was not still on the traditional AI side. It was focusing on reinforcement learning, small model solve a small problem. It was nothing about agentic AI. Yeah, but it was very interesting. It was mostly research focused. We're gonna publish some papers and work with the media research. And I think so. We try some reinforcement learning, basically tools to help designing the standard cells of digital chips better. So that was mostly a research focused project.
Then how you got into Cadence?
Yeah, Cadence was like my first full time job. I think so Cadence was like this give you some context, right? So this when we are talking about chip design software, so the industry is called EDA, like electronic design automation, and so this is a very old area. Like it's not there's nothing about AI when it started from the 80s when the chips becoming more complex, and so as of today, it's very consolidated by two companies and worldwide. So the market is about like 10 billion annual revenue. So, but it's mostly shared by Cadence and Synopsys. So there's two giant U.S. companies. um, and I think at that time, actually, so originally decided to go to Amazon. I took their offer, which they gave me a very good offer, and then unfortunately they withdrew my offer right before I graduated. So there's a bunch of people. So at the end of 2022, 2023, the Amazon they are not doing well. They are just withdrawing offers. So I was one of them. So they withdraw my offer like right before I graduated. I was done with my PhD program. Yeah, which is crazy. And what?
How did you feel then when they took back the offer?
I feel pretty bad, of course, right? So I think it's very irresponsible, which has been the way for Amazon. Like
Share
this,
me the way for Amazon.
yeah,
Okay,
yeah,
continue.
I think yes, yeah. I would say never. I was if you anyone saw your podcast or my suggestion is to never work for Amazon. Like just it's not a tech company. It's like the money can be good, but it's just very political. It's not very yeah. Anyway, I can discuss about that like for a whole day. Anyway, yeah. I
Okay.
was so yeah. So anyways, yeah.
Even few of my friends tell Amazon is yeah, don't join Amazon because Amazon culture doesn't have the standards.
Yeah, yeah, exactly. So anyway, yeah, yeah, it is what it is. Yeah. So at that time, so they withdraw my offer, so I have to find somewhere to work, and so Cadence is not my first choice because I know it's a good company, but they're mostly doing only like incremental innovation, like theirs, because they have a lot of established customers like Apple and Nvidia, and they're gonna spend most of the energy on supporting the existing customer. So the focus is not really on innovations or like adopting AI. So I know that, but because I need to find a place to work at that time, and I think because I have worked with Cadence folks, collaborate with Cadence folks for my PhD, so I figured out that was a good time. That was a relatively good choice for me. So I joined Cadence right out of PhD program, and Cadence was mostly focusing on still like AI for chip design, this bigger hat. but it was still more or less on smaller models. So I tried some, graph neural network models for optimize their like physical design flow. So basically, I work on the digital part, like digital chips, software, and digital chips. You're gonna do a bunch of things, and also very important thing is to optimize the power and the timing of the chips. So I mostly is leading a deep learning graph neural networks project on optimizing the power and performance of the chips. And got to learn about this industry scale software. Um, I was there for like 2.5 years. Yeah, so it was a relatively short period of time. Yeah, and then I just joined this current company April last year. Yeah.
Great. I mean, uh, there was one question in my mind. How are you managing your finances all throughout these years? Because if I recently graduated out of college, then I feel like I'm I'm living in my dad basements and I have to go get some finances done. Is there any thought running in your mind about finances and stuff all these years, and how are we managing those?
I think yeah. So because the tuition in China is pretty cheap, so I mean, before I came here, I just don't worry that much about the finance. And I think for my master program, I think my parents supported me for the master program, but it was private school, but it's only 1 year, so that's doesn't cost that much. And so once I get into my PhD program, I think the nice thing about the PhD program in US is that they they give is mostly fully funded. So meaning that the university like Carnegie Mellon, they will pay my tuition, and they give you like a monthly stipend, which is usually enough for cover your basic living, like rent a place, and then your grocery and basic stuff. And I think nice thing about starting as E or electrical engineering or CS is that you get a lot of chance to do internships. So actually, like from my I think after my second year of PhD, I have been doing internships every summer. Like from the third year, I've been doing, I did 3 internships during my PhD. And the summer internships really helps with my financial situation. So I am in the tech company, the internships they pay pretty well. So also when I was at PhD, so I most of the time I get more pay from the internships than what I'm getting from the schools. Yeah, but I still appreciate, but it's like I appreciate the funding from Carnegie Mellon, right? Because it covers the tuition and it covers the basics. Yeah. So I would say, would you, if you think about coming to States to study, I would say applying a PhD program it's a very good choice. Yeah. So I would say like it's like after I came to States, it's pretty much so. Although I was in school for like another 5 or 6 years, I was able to pretty much be independent, to cover all the finance. Yeah, yeah.
Now, if someone is starting out just in career and they want to learn about these LLMs, foundational models, and AI in general, where can they start? Is there any book that you recommend? Is there any URL that you recommend? Is there any person that
So you mean
course or something?
folks from like starting from scratch, right? Is it or like
Not scratch, maybe a computer science student who know basics of coding, basics of CS fundamental, etc.
I see. I don't know if there's a book or I think the best way for me I think to pick it up is just go to really some blog post about in general introduction about what are these LLM models and what are the applications. I think there's reading the blog post will be the best, and try stuff, try things yourself. I mean, especially these days, it's more about this agentic AI, right? I think things are evolving very fast. That really the textbook is lagging behind. The speed of people writing and publishing textbook is really is sort of lagging behind. It's like I feel like if you look at like if you want to do LLM, then maybe there are some textbooks or there are some books in general. But if you look at agentic AI, maybe there's not so many because I think it's really evolving very fast, and the speed is publishing is not catching up. Yeah, yeah.
Then, is there any tactic that you use in order to get stuff done in less time?
For my yeah, it's really a lot these days. A lot of distraction from the social medias to hard people make it hard to get things done. Yes, I think when I'm like working on my day jobs and like when I'm working at night on my study and my own project, I really try to yeah, like you said, turn off all the social media and then um, sort of compartment the time to just having dedicated focus time on either work related items or my own like learning or project. Yeah, so to minimize the distractions as much as possible. Yeah. Yeah, I tend to use less social media. I only use Instagram or like LinkedIn is more professional. Yeah, I really enjoy using LinkedIn. Um, I would highly recommend. I've been using LinkedIn actually before I came to United States. So I've been using that for 10 years. So uh, yeah, I think the other social media like Instagram is mostly for like entertainment, for like hang out with friends. But I think LinkedIn is really, really good. Like, I mean, people have mixed people like kind of like bragging on LinkedIn sort of things. There's mixed opinion, but I personally really enjoy LinkedIn. Right, it's like um, you gotta connect with people, like relevant people, and the more you use LinkedIn, it's like a magnetic. I feel it's like the more you use it, the after a while it's becoming kind of like a magnetic kind of thing. So you gotta connect with people relevant, almost like naturally. Um, yeah, and you gonna. I think one thing is that I enjoy using LinkedIn is that it's like a gauge of relevance of people. I tend not to gauge people that way, but I think it's a one thing. For instance, if I want to find ways like to talk to people who know AI and chip design, and I check LinkedIn and the common friends because I have a lot of friends in this AI for chip design, and if I find me and the guy who's have a lot of like common friends, that probably means that hey, this is the guy who's in this field for a while, so this relevant guy. But I mean, this is not like golden standard, so it's like not you should not like just not talk to someone because you don't have common friends. But I find it's a pretty useful way to kind of
What is happiness mean to you?
I mean spending time with families and friends. I think quality time with them, just get connected with friends and families. I think it's happiness. I think it's very important, probably the most important thing. And I think really because another, like happiness also means really making some real impact with the things you can do to the society. Because I think one thing I personally don't really like bigger companies like big tech is like there's more stability. There's like sort of safety nets, but really it's like you didn't see, and you are doing meaningful things, but you don't really see the feedbacks very directly, right? So you are like big company, you're working on maybe a subset of a project, so don't see this feedbacks. Because for me, I think happiness coming from really building something meaningful and people having a positive impact um, in other people's lives. And I think working at startups is like it's one thing. There's pros and cons, but I think this side, making real impact and see the feedbacks, it's one of the nice things. Yeah.
Correct. Do you miss your friends in Shanghai?
Oh yeah. So friends in Shanghai. Yeah. So haven't been back to China since COVID. Actually, my parents is they can travel to States, so like they travel back and forth. Yeah, but yeah, yeah, but not, right now there's these days there's social media, so you're gonna see what friends are doing. Yeah, but yeah, I really me and my wife, so we both lived in Shanghai for a while, so really enjoy living in Shanghai. Yeah, so yeah, it's probably if I have a lot of money, I'll spend part of it. If I'm getting really rich, I'll spend some time in Shanghai, sometime in yeah, it's yeah more things to do. Yeah, but if I think if I want to do AI, this like because now I'm doing the AI, I think SF is a perfect place. I like if you ever consider like doing AI related thing, I think SF is probably the best place. It's just there's so many venture and there's so many like relevant and optimistic people. I think there's like probably no other cities in the world will have this kind of ecosystem. Yeah.
Then after that, you're hiring for a bunch of roles. Like, can you tell what are you guys are hiring bunch of roles, right? Can you tell those because
Mhm.
people who might watching this video might interested in joining GenAlpha Transistor.
Yeah, yeah, I can sort of give a high level. So basically, give a brief introduction. So we are basically making building agentic AIs for chip design. So particularly focusing on analog part, which is the least automated part. So with agentic AI, to so the value proposition is really to bring efficiency and to the designers. So you can think of that as like a cloud code or like a coding agent, but for hardware. And I think the nice thing about I'm not trying to like advertise, right? So it's like sincere and like observations. I think a nice thing about this application area is that chip design. I think it's both in United States and other world, other elsewhere, like worldwide. There's a like labor shortage. So there's a constant shortage of people doing chip design, especially experienced engineer. Um, and I think so we are kind of like enhancing this labor effort in this area. So because like software, you usually like in US and China, like India, there's like tons of software, right? So and people are discussing like coding agent replacing people's jobs, and there's like layoff already coming. I think hardware is really not. It's a very different. It's like hardware. So if we're building this really highly efficient like smart tool, um, so first of all, it's like enhancing existing designers' capability. And I think another very meaningful thing is that so if you make the tool intuitive, easier to use, it will bring more younger people to this area. Because I think if you talk to a chip designer, hardware industry, it's a very big industry, right? So, but it's like usually if you look at this like Apple Silicon or like Nvidia Silicon chip design team, they are mostly like maybe boomers like or like the medium age is like in their like 50s. I don't know. So there's like of young people, and I think one reason is that the tool is very difficult to use. The tool is very forbidding. The learning barrier is very high. So I think if you make the tool better, there will be more younger people going to this field. So I think that's very meaningful. So we have been hiring. So we are like a pre-seed. So we are we have the defense contract. We're pretty well funded. So right now we have 6 people. Soon become 7 people, like full time. Bunch of other like contingent people or as consultant. Um, so engineers, including the CEO, right now 6 people. By end of month we'll have 7. So we are thinking about like doubling the team pretty soon. So mostly hiring people like experienced softwares, a couple of different areas. So one is this things around agentic AI. The second is building this EDA tools. The third is to having experience on the GUI, building the experienced folks building the GUI, the front end. So mostly these 3 areas like GUI tool and this AI agentic AI infra. But in general, like I think because we are building everything in house, most of the things in house. So general like software, especially backend guys, experience with distributed computing, cloud system will be very helpful. Um, yeah. So yeah, it's very interesting time because now with this coding agent, maybe I like you. If the thing we want to build, like back to 5 years ago, you probably have need to have like 30 people, like 30 software. Right now we have like 6 or 7, and we already have people from very diverse background. So we have like for me, I'm on the AI and tool side. So we have folks who's like very experienced in this distributed system, cloud computing, and we have folks who's from gaming background. This was it was basically from Zynga or like Roblox was doing gaming because we need the very high performance GUI, and we also have like kind of like deep learning engineers from Amazon who's graduated from MIT. So it's like very very strong team, I would say. So me personally, I find it's very rewarding learning experience. So because I'm still relatively early mid career, so it's very good learning
Yeah.
experience. Yeah.
But if someone want to reach out to you, what place they can reach out to you? Instagram, GitHub, LinkedIn. What is a good place?
They can add me on LinkedIn, or I can share my working email to you. If you can share somewhere, I can let me. Oh, you have my
Yeah,
email,
yeah.
right? You have my
I'll
working
paste it in the description.
email. Yeah, that would work. So yeah, so let me know if anyone is interested. Yeah, so they can. If anyone interested, they can just reach out to me. Yeah, glad to talk more.